Hi everyone, welcome to my MacFi channel. In my last video, we discussed energy, but in this video, we will solve some problems based on potential energy and kinetic energy. Mathematical expression of potential energy is equal to mgh and kinetic energy is equal to half mv square. Let's solve some problems. Problem number 1, if 10 kilojoule of work is done to bring a body of mass 50 gram, then find at what height the body is lifted. So here work done is equal to potential energy is equal to m into g into h. But it is given work done is equal to 10 kilojoule. So 10 into 10 to the power 3 joules. Since kilojoule is mega unit, so we have to convert it into SI unit. Should be is equal to mass. Mass is 50 gram. 50 gram should be converted into kg. So 50 by 1000 kg into g is 10 meter per second square into height is to find out. So 0, 0 and these two zeros will cut 5 2s are 10. That implies h is equal to 2 into 10 to the power 4 meter. So the body should be lifted at 2 into 10 to the power 4 meter when 10 kilojoule of work is done. Next, problem number 2. If mass of a body is tripled and velocity is doubled, then find kinetic energy. Governing formula of kinetic energy is equal to half mv square. Since mass of a body is tripled, let initial mass of the body is m. Since mass is tripled, then final mass of the body is thrice m. Velocity is double. Initial velocity is equal to v. Then final velocity is equal to twice v. Then find kinetic energy. So first case kinetic energy is equal to half m into v square. And in second case kinetic energy 2 is equal to half into 3m into twice v whole square. That implies half m v square into 3 into 2 square means 4, 12. That is equal to 12 into kinetic energy 1. So we can say kinetic energy will be 12 times of previous kinetic energy. So now let's solve problem number 3. If mass of a body is doubled and height is tripled, find potential energy. So we know mathematical expression of potential energy is mgh. So we have to write first potential energy is equal to mgh. Mass of a body is doubled. Let initial mass of the body is m. Height is triple. First mass of a body is double. That implies final mass is equal to twice m. And height is triple. So initial height is equal to h. So final height is equal to 3 into h. Find potential energy. We know acceleration due to gravity is constant. So in both the cases g will be g. So potential energy in first case is equal to mgh and potential energy in second case is equal to m means twice m, g means g and h means thrice h is equal to 6 mgh. That implies 6 into potential energy at first case. So we can say potential energy will be 6 times potential energy in previous case. Now we have to know what is the relation between momentum and kinetic energy. We know momentum is product of mass and velocity, whereas kinetic energy is equal to half mv square. So let's start. Since P is equal to m into v and kinetic energy is equal to half mv square. So we squaring equation 1, we are getting P square is equal to m square v square. Now putting this value here, but we can write kinetic energy is equal to half into m square v square into 1 by m. Means we are dividing m also multiplying m to get the relation between kinetic energy and momentum. So you can write, one can write this is equal to p square. M square v square is equal to p square divided by twice m. So this is the relation between kinetic energy and momentum. Kinetic energy is equal to p square by twice m. Now we are going to solve a problem based on relation between momentum and kinetic energy. Question is, if momentum of a body of mass 10 kg is 20 kg meter per second, find its kinetic energy. So if momentum of a body of mass 10 kg, so mass is equal to 10 kg and momentum in mv is equal to 20 kg meter per second, kg meter per second. And so you can write kinetic energy is equal, since kinetic energy is equal to p square by twice n, so kinetic energy is equal to p square, that is p is equal to 20 kg meter per second, means 20 into 20 divided by twice n, 2 into 10. So 10, 2 and 20, that is equal to 20 joule. So kinetic energy of the body is 20 joule. Now if we plot total energy versus height, then we will get this type of two lines. We already know when height is equal to 0, then potential energy is equal to 0. If we are increasing height, then potential energy will increase uniformly. So it will give a straight line. At maximum height, potential energy will be maximum. What will happen with kinetic energy? At maximum height, potential energy is maximum, but kinetic energy is minimum. When height decreases, kinetic energy increases uniformly, and it reaches maximum when height is equal to 0. That implies total energy is remaining constant. Amount of decrease in potential energy is equal to amount of increase in kinetic energy, as well as at h/2 height, potential energy is exactly equal to kinetic energy. Okay, now we have to know another common unit of heat energy, that is calorie, which we generally use in our day-to-day life. What is calorie? We have to know definition of calorie. Calorie is the amount of heat required to raise temperature of 1 gram of body by 1 degree centigrade. So there must be a relation between calorie and joule. Joule is SI unit of energy, where calorie is CGS unit of energy. What is relation between them? 1 calorie is equal to 4.2 joule. Now let us solve a problem based on total conservation of mechanical energy. A ball is dropped from a height of 19.6 meter. Find its velocity when it reaches the ground. We know from law of conservation of mechanical energy, mgh is equal to half mv square. m will cancel out, so v square is equal to 2gh, or v is equal to root of 2gh. This is a most important mathematical expression of velocity in case of a freely falling body. So here, by using this formula, we can find out velocity. So velocity is equal to root over 2 into 9.8 into 19.6. That is equal to, here also 19.6, another 19.6. So velocity is equal to 19.6 meter per second. Okay. Now let us take another example. An object of mass 40 kg is dropped from a height 8 meter. Find its kinetic energy when it is 2 meter above the ground. Let us take the object was at A, 8 meter above the ground. So here its potential energy is maximum, that is energy due to 8 meter, but kinetic energy was 0. Since it is dropped, then potential energy decreases since height decreases, and kinetic energy increases. So at 2 meter above the ground, loss in potential energy due to 6 meter is equal to kinetic energy 2 meter above the ground. So we can say kinetic energy 2 meter above the ground is equal to 2 meter above the ground is equal to potential energy decrease in potential energy due to 6 meter. That implies kinetic energy at 2 meter above the ground is equal to m into g into 6 in this much joule. That is equal to 40 into 10 into 6 this much joule, that is 2400 joule or 2.4 kilojoule. Okay, understood. Now we will illustrate law of conservation of energy in a pendulum. Pendulum is a high mass bob suspended from a string. When it is pulled to the left, then the energy supplied to it is stored within Bob as potential energy. So at this position, potential energy becomes maximum and kinetic energy of the pendulum it becomes zero. When it is released, its velocity increases and height decreases. So potential energy decreases and kinetic energy increases. At its mean position, kinetic energy becomes maximum and potential energy becomes zero. Due to inertia of motion, it moves towards right. During this movement, its velocity decreases but height increases. So potential energy increases and kinetic energy decreases. At extreme right, again potential energy becomes maximum and kinetic energy becomes zero. So we can say potential energy plus kinetic energy, that is mechanical energy, remains constant. This illustrates law of conservation of energy of pendulum. But eventually pendulum comes to rest. This happens due to transferring of energy to air and also due to friction at the point of suspension. But that means the rule is violated. Energy conservation is violated. It is not correct. It is merely changes its form, not destroyed. Okay. Now we have to know what is HP. HP, first we have to know what is power. Power is called rate of doing work. And what is work? What is unit of work? That is joule. And what is unit of time? That is second. So joule per second, that is watt. After the name of James Watt, it is after his name, SI unit of power is called watt. Now what is HP? HP is another unit of power. James Watt did some experiments with strong horses, and he determined that horses can lift 550 pounds by a distance of 1 feet in 1 second. He termed this power of horse as horsepower, and that horsepower is equal to 746 watt. That is in SI. This is relation between horsepower and watt. Now what is kilowatt? 1 kilowatt is equal to 1000 watt. And what is kilowatt hour? It is kilowatt is SI bigger unit of power. Horsepower is also unit of power, but kilowatt hour is unit of energy. It is unit of electrical energy or commercial unit of electrical energy. So how we can find out relation between kilowatt hour and joule? 1 kilowatt hour is equal to 1 kilowatt into 1 hour. Since work done is equal to power into time, so here power into time means work done, that is energy. 1 kilowatt is equal to 1000 watt and 1 hour is equal to 3600 second. 1000 watt means 1000 joule per second into 3600 second. Second and second will cancel out, that is 3.6 into 10 to the power 6 joule. So 1 kilowatt hour is commercial unit of electrical energy or board of trade unit, which is equal to 3.6 into 10 to the power 6 joule. Let us consider other problems. A woman pulls a bucket of water of mass 5 kg. So mass is equal to 5 kg from a well 10 meter deep. So h is equal to 10 meter in 10 seconds. So acceleration due to gravity is equal to 10. Acceleration due to gravity is equal to 10 meter per second square. So work done is equal to mgh, and in 10 seconds time is equal to 10 seconds. So power is equal to work done by time taken is equal to 5 into 10 into 10 divided by 10. That is equal to 50 joule, 50 watt. So work done, power is in kilowatt. So in kilowatt, 50 into 10 to the power minus 3 or 5 into 10 to the power kilowatt, or 5 into 10 to the power minus 2 kilowatt. Okay. Now next question. Find unit of electrical energy. We know unit of electrical energy is equal to kilowatt hour consumed in 10 hours. Here time is equal to 10 hour. 10 hours by 4 devices of power 1000 watt each. Since 1000 watt each, so for 4 devices power is equal to 4 into 1000 watt. That implies 4 kilowatt. Since 4 kilowatt and 10 hours, so unit is equal to, or electrical energy consumed, or electrical energy consumed in unit is equal to 4 kilowatt into 10 hour, that is 40 unit, 40 kilowatt hour or 40 unit. Thank you for watching. This is all about chapter work power energy. For the other chapters, please watch next videos. Till then, bye bye.